Good morning, everyone. Let's begin the morning seminar. This morning seminar is produced by Nissan Chemical Corporation. And Nissan Chemical Corporation is my collaborator. In this morning seminar, Norio Hashimoto in Nissan Chemical America Corporation will present the data concerning innovative spheroid manufacturing and transportation platform in Nissan Chemical. So, Mr. Hashimoto, please.
Thank you very much. Thank you for introduction, Dr. Fukuda, and thank you for organizers for these opportunities. And good morning. Thank you very much for coming today without breakfast. So I'm impressed some people accept Nissan Chemical here. Today, I would like to talk about our spheroid manufacturing and transportation platforms. Before starting the science presentation, I would like to introduce Nissan Chemical very briefly and show you the spheroid manufacturing and the storage technologies. Our company, Nissan Chemical, is a medium-sized chemical company based in Tokyo, Japan. And we started our business in 1887 as a chemical fertilizer company. Now they're around 130 years old. However, they're still medium-sized, 2,700 employees and 200 billion yen sales. We have 4 main businesses, including the chemicals, performance materials, agrochemicals, including the animal drugs, and healthcare, including the pharmaceutical businesses. And we have another division named the Planning and Development Division for the new business development. We have some healthcare businesses in healthcare and planning and development. So we would like to show you some of the healthcare focuses here. Actually, we have a wide range of the focuses in our healthcare field. Custom chemicals, including the CDMO business for the small molecule and the peptides. And drug discovery activities using the small molecule modalities and oligonucleotide ASO platforms. And in a regenerative medicine field, we have some materials for the cell therapy field, including the cell culture scaffold and anti-adhesion coatings for the spheroid manufacturing on the surface of the plastics, and some of the cosmetic materials. So we have 2 approved drugs named Livaro, pitavastatin. This is a cholesterol lowering drug. And Randel, this is a calcium channel blocker for hypertension. So, and also we have an ion channel blocker named NTC81 for the genetic bradycardia treatment. So we have researched cardiovascular field for a long time, and we have some background of the evaluation of the cardiovascular field. So we would like to use new technologies related to the scaffold and anti-adhesion coating using for the cardiovascular field drug development in the future. So as you know, the spheroid and the organoid is good for the good technologies for the drug discovery and the development. For example, bridges the gap between 2D cell culture and the in vivo models. And also increases the intracellular interaction and cell matrix signaling. And for the clinical usage, prolongs the stability after transplantation. However, there is some challenging, especially for the clinical applications. One of the size control and the scaling up. And after the manufacturing, the shelf life is relatively short, so it's very difficult to transport internationally. And also the quality control is, of end product is challenging point, we think. So now, Nissan Chemical has two types of solution for the spheroid manufacturing and transportation. First one, named the Preverex CAT system. This system is a highly precise and scalable spheroid production system. And another one is the FSM Advanced Shear Preparation Kit. This is a secure cell transportation system at room temperature for around 1 week. So the fundamental technologies, Nissan Chemical has anti-adhesion coatings. We have named the Preverex. We have two types of series of the Preverex product named CC and AP. Preverex CC is good for the anti-cell adhesion. This is good for the spheroid formulation on the surface of plastics. AP is anti-protein adhesion. This is good for the recovery of the biomaterials, such as nucleic acid, antibody, and some of the peptides. These two types of product is applicable to the gamma sterilization and autoclaves, and applicable to the wide range of the surfaces, like polystyrene, PDMS, and glasses. Now, we developed a new type of spheroid manufacturing system on the surface of the plastics using the Preverex anti-adhesion coating materials and our patented adhesive material named CAT. So first, we coated the anti-adhesion material on the surface of the substances. After that, we spotted CAT material using the inkjet system, like this. If so, the cell put together on the surface of the CAT materials and makes spheroid spontaneously. So we can make a spheroid. This is an example of the cancer cell. The first, put together on the surface, and after that, make a spheroid within a few days. So I would like to show you the one of the video for the spheroid formulation. First, seeding a cell and put together on the surface of the CAT materials, and make a spheroid spontaneously like this. So I will show you again. And one of the good points is we can use any type of surfaces. So now we have just a 6-well plate and 24-well plate for drug discovery purposes. However, we can expand the size of the surfaces for the massive production in the future. And also making the spheroid stick off from the surface easily with pipetting without enzymatic treatment. So it's easy to harvest a cell, harvest a spheroid after manufacturing. So another good point is we can control the size according to the CAT diameter in these technologies. So there is the clear positive relationship between spheroid diameter and CAT spot size. So if you would like to have a 100 micrometer diameter spheroid, you can use around 200 micrometer CAT spots. If you would like to 300 micrometer of spheroid, you can use around 1,000 micrometer CAT spots. So you can control the size according to the CAT spot size. And also, I would like to emphasize the size control is very good using these technologies. So another type of, this is another story using our polymer named FP003. We launched the FSM Advanced Shear Preparation Kit, including the polymer named the FP003B and the harvesting buffer So the FP003 make a chelate with a divalent ion in the media, like a calcium ion, and the suspended cell and the spheroid. However, interestingly, this solution is like a water, viscosity is like a water. So, if you, after transportation or storage, just add 10% of harvesting buffer and the centrifugation, you can harvest the cell easily. This harvesting buffer including just a chelate breaker. There is almost no damage on the cell. So this is an example of this storage technologies. So after expansion using the 2D cell culture of the adipose-derived mesenchymal stromal cell, and make a spheroid on the surface of the microwave plate. So after that, we store the cell in a vessel, plastic tube, or a gas permeable bag. And the condition is around the room temperature from 4 degree to 25 degree. And during the up to around the 2 weeks storage, you don't need change the media. After storage, you can use a harvesting buffer to harvesting the cell. So this condition is now the 2 million cells per milliliter. And so as you can see, the viability is the higher than 95% for 1 week at a room temperature, 25 degree. And also the positive and the negative marker of MSC did not change before and after the storage using our polymer. From this slide, I would like to show you some of the application in a cardiovascular field. So compared with the other type of coating material like polyhammer, the polyhammer case is the coating is relatively thick like this. However, the Preverex is very thin coating. So the Preverex is applicable to the complex surfaces like a microwave plate. So and also the on the Preverex coated microwave plate, you can make a IPS-derived cardiomyocyte spheroid for around 1 week. So now our collaborator Hartsheet using the Preverex CC1 coated microwave plate for the clinical usages. Our Preverex is, does not include the animal-derived component, and also the elution is very limited. So the details of this technology will be presented in a poster today by Ms. Hiroi at P16. Please visit if you are interested in these technologies. So next example is making the spheroid using the CAT system. So using the CAT system, you can make an IPS-derived cardiomyocyte spheroid like this within a few days, very fast, faster than the microwave plate conditions. And we need some of the validation from now on. However, in the preliminary study, the size of distribution is like this, and relatively good, and around 200 micrometer diameters. And also the function is observed using the calcium transit assay. The beating is observed in these conditions. For the details, Mr. Suzuki will make a presentation at P19 in the poster today. So final example is a cardiomyocyte spheroid storage using our FP003 technologies. So after making the spheroid, we store the cell in the media with FP003 at several conditions of the temperatures from 4 to 37 degrees. So if so, the except 37 degree, the viability is kept almost 100%. So 37 degree is beating, so nutrition consumption is higher than other conditions. So the viability is lower than other conditions, but the room temperature or less is good to store the spheroid. And the spheroid condition is like this. And after storage, function is observed. It means the beating rate is same as same before and after the storage, like this. So one of the mechanisms of action to store the viability using the FP003 is just a suspension. There is no the big spheroid observed, no stick to each other of the spheroid. So the detail will presented by Ms. Anno in a poster P4 today. So in conclusion, we developed some of the innovative technologies. First, previous CAT system. This is a combination of our adhesive materials and anti-adhesive materials, which are for the self-organized, site-controlled, and massive scale spheroid production. And another technology is FP003 FTM Advanced CR preparation kit, transform the 2D cell culture media into 3D. And the spheroid kept in media with FP003B were viable over 1 week at room temperature or cold conditions. So the FP003 is also does not include the animal-derived composition, and we will develop the clinical grade of the product from now on for the future development. So we hope our solution will contribute the development of spheroid therapy in the future. If you are interested in this kind of technologies, please contact us through this email address, or just contact me after this presentation. Thank you very much for your attention.
Thank you, Mr. Hashimoto, for a nice presentation. The paper is open for discussion. Is there any questions or comment? So Nissan Chemical has a lot of technique that can applicable to the regenerative medicine. So if you have any consultation, please contact him. So Mr. Hashimoto, thank you very much.
Thank you.